All right, good enough. So Unit 2, Section 1 at the top, the first thing that it asks is the essential question. It says, what is a function? Okay, so when we say what is a function, you're going to try to learn, that is our main thing for today. And then how do we state the domain? So you're going to find the domain of a function. How do you find the range of a function? And then how do you find intervals where it is increasing and intervals where it is decreasing? So that's our main thing. So the first thing that we want to look at is a relation. So we want to talk about what is a relation and then kind of what is a function. Okay? So a relation is a set of ordered pairs. Okay? That is a relation. So a relation is a set of ordered pairs. So ordered pairs are just like x and y. That's going to be what is a relation. Just a set of ordered pairs. And then we're going to talk about, is it a function? So again, a relation, I can show you some different ways on here. A relation could be written like this: -2, 1, -2, 3, 0, -3, 1, 4, 3, 1. You could also write a relation like this with your x and y values. You could also write a relation like this on a graph. You could also write a relation like this, where you're mapping x and y's, but those are your x and y's. That's a relation. Now, a function is a relation. So on the other hand, a function is a special kind of relation. So this is the issue here. A function is also a set of ordered pairs. However, every x value must be associated to only one y value. So every x has to go to one y. So every x value must be associated to only one y value. That means, like, if I have x as the number 2, so if I have a 2 for x, it cannot go to 1 for y and also go to 5 for y. So if you look back at one of these up here, like this one, this is not a function because -2 goes to 1 and -2 also goes to 3. So some people say the x's can't repeat. That's fine if you think of it that way. But basically what it means is each x, so -2 can only go to one y. It can't go to two different y's. So this -2 goes to 1 and it also goes to 3. Now your y's can repeat, so that's fine. But your x's cannot. You can't have x's that go to two different y's. So some people mix that up. You got to be careful on that. The domain, remember, is just the list of your x values. So the domain is just your x values in the graph. All possible x values is called the domain. The domain is the set of all x values. The range then is the set of all your possible y values. Yes?
Can you go back to the definition of the function?
Yeah. So the domain is all the possible x values, and the range is all the possible y values. If you go back to a function is the same as a relation, except every x value must be associated to only one y value. So basically today, when we go to our problems, what we're going to be working on is what is the domain, what is the range, and is it a function or not? Three things. You're going to have to tell what the domain is, what the range is, and whether something is a function or is not a function. Those are basically the three big things that you have to work on. Okay? So example 1 says, what are the domain and range of this relation. And I'm going to pull that up on the screen and zoom in for you. So it says, what are the domain and range of this relation? So the domain is going to be all of our x values, right? So the domain on this one would be -4, -3, 0, 1, and 3. So it's going to be all of your x values. That's your domain. So then your range is going to be all of your y values. So in this case, that would be 0, 1, -2, 2, and 3. Now, you could write it in order. A lot of times they're going to put it in order, so you could move the -2 first and go from least to greatest. A lot of times they're going to do that. But that's what we're looking at. And then we have the question of, is this a function? What about this one? Is this going to be a function? Yeah, this one is a function. So you have 5 different x values. You have -4 going to 0, -3 going to 1, 0 going to -2, 1 going to 2, and 3 to 3. So yes, this is a function. Okay. Now, that is if you're given some points. That's a way of telling if it's a function or not. Then you can look at a graph. Does anybody remember on a graph how you can tell if something is a function or not? What's it called?
If it passes like one.
It's called, it's the vertical line test. So if it passes the vertical line test, it will be a function. If it doesn't, it's not. So this right here, if I make a vertical line straight up and down through it at any point, if it crosses more than once, so see like this one, it would cross here, and it would also cross here, then we would say no, this is not a function because it fails the vertical line test. So if you want to explain why or why not, again, it fails the vertical line test. Now, if it fails the vertical line test, what that means is look at the point. So like -2 crosses at like, there's a point -2, 2, something like that. It's close to that. And there's also a point -2, -2. So like there's 2 points here with the same x value but different y's. So that's the issue. So it's the same x value but 2 different y's, and you can't have that for it to be a function. Now here, if I made a vertical line anywhere through this, notice that red line, it only crosses once. So like here, here, here. So you're seeing that it only crosses one time. It doesn't cross twice like it did in example A. So in this one, we would say, yes, it is a function. Okay? Each x value goes to 1y. So it does not, in this case, you don't have any x's that repeat. You don't have any spots where it is repeating or it is going over what it should be. Okay, the x's do not repeat in that case. So each x goes with 1y in part B. So you should see why A is not a function when you look at the graph. You see why B is a function when you look at the graph. Okay, so we're going to move down. So now, as you move to the bottom of the first page, it just says, determining if an equation is a function. These are things that help you determine it if you're still not really sure if you have an equation. 2 things cannot be true, it says. Y cannot be an absolute value bars. Okay, the y cannot be an absolute value bars. And y cannot be raised to an even power. So these are just rules to where you don't even have to look at the graph, or you don't even have to have ordered pairs, x and y values. You can just know by looking at the equation if it is a function or not. So what about in A? is that going to be a function?
Yes.
Yeah, it's a function because, so y is not an absolute value, and y is not raised to an even power. It's y to the first power. So that is a function, yes. So it's good. All right, B?
No.
B is no because y is to the second power. So no, it is not a function. And then C
Yes.
is yes. It is a function. So you just have y there. Now, another one that would be no that I can write on here, if you had like x equals the absolute value of y minus 3, something like that, that would be a no. So y is an absolute value, so that's a no, it's not a function. So B, and I can make this and call it D. These two are two ways when you see an equation that you know it's automatically not a function. Everything else is going to be okay to determine if an equation is a function or not. So that's page 1. And you're going to have to do some of these on IXL too. So you have a little bit on the on Canvas, and then there's like an IXL that asks is it a function or not. So some of these things will be used in just a little bit. All right, so on page 2, we want to know, this is where it gets a little bit tricky, we want to know whether it is increasing, decreasing, or constant. So an interval where something is increasing means as you go left to right, so I'll write it down. So as you go left to right, the graph is going up. Okay, an interval that's decreasing is the same thing. As you go left to right, the graph is going down. And then an interval that's constant means as you're going left to right, the graph stays the same. Okay, so we're going to look at whether as we look at the graph, we're going to look at as we go left to right, is it going up, is it going down, or is it staying the same? And we're also going to know from what intervals. Intervals means from this number to this number, what is it doing? So from like -5 to 2, is it increasing? And then from 2 to 10, maybe it's decreasing. And then from 10 to 20, maybe it's increasing again. Like it could be going up, down, up, down, up, down. Could be doing all kinds of different stuff. Now, you're going to look at example 3. And it says, given each representation of a function, determine the domain and range. Then determine the intervals in which the function is increasing, decreasing, and or constant. All right, so we got a lot of stuff to do first. So determine the domain and range. So the domain, okay, this is going to be a little bit different than what you're used to. These have points on both ends, so we know it stops there. So what's the domain is left and right. What's the furthest that it goes to the left?
-5.
-5. And the furthest it goes to the right
5.
is +5. So your domain goes from -5 to +5. That's how you can write that. The first number you write for domain should be the furthest that it goes to the left. The next number you write for domain is the furthest it goes to the right. Okay? Your range would be the lowest it goes to and the highest it goes to. So what's the lowest that it goes to?
0.
That's 0. So right here, we're at 0. And the highest it goes to is 10. So the range goes from 0 to 10. So we've got our domain and range for A. Then it says determine the intervals in which the function is increasing, decreasing, and are constant. So we're looking left to right. If we look left to right, is it ever going down? If you're looking at it from left to right, is it ever going down?
No.
No. If you look at it from left to right, it's never going the same. It's always going up. So in this one, you can see we only have increasing. So that's the only time. it is increasing from -5 to 5. Okay? And you could write that like this, like the order pair, or you could write it in words. But it is increasing from, and we talk about our x's, it's increasing from -5 to +5. Okay? So we're going to go to B and kind of do the same thing. We're going to do domain, range, and then we'll talk about whether it's increasing, decreasing, or staying constant. So in B, the increasing part, you see it's not going up, but we can tell this one's going down, so we already know it's going down. But what is our domain? So where does the x stop on the left? To the left.
0.
It stops right here at 0. Okay? Where does x stop going to the right? It does not. So what do we put? Infinity. So it goes from 0 to infinity. That's where people really get confused. A lot of people put 12 on this one sometimes when we do this one to start off with. Because they're like, well, it looks like 12. The arrow means it's going to continue on, right? Forever and ever and ever. Okay? The range. What would be the lowest that this graph goes to? Negative infinity, right? Because it'll keep going down. That arrow means it keeps going down. So the range is from negative infinity all the way up to 5. Good. So we start dealing with infinity. That means if you see an arrow, you have to assume that it is going to continue. Okay? For forever and ever. Way off the graph. So now we see, reading this from left to right, it's never increasing, it's never staying the same, it's always decreasing. So it is decreasing from 0 to infinity. So all the way from 0 to infinity, that graph is going down. So if we kept going further and further to the right, you would still see that graph going down from 0 all the way until infinity. So that was example 3 there on there. That was A and B. Now, C, D, E, and F, again, now we get into like some trickier stuff. So things, they're going to look a little bit different. These are called piecewise functions, which is going to be later on in Unit 2. So it means there's more than one thing happening. Like in A and B, there was only one thing happening. It was going up and it was going down. In C, D, E, and F, they're going up and down and across and all over. So there's all kinds of different things happening to these graphs. So that's going to change our interval part. It's going to make it a little bit more difficult to write. But the domain and range part should still be hopefully the same, just as easy. So let's pull those 4 up. I'll zoom out just a little so we can get them all on the same page. There we go. All right. So for each one, we're going to put, and I'm going to kind of abbreviate this. We're going to put the domain, the range, and then we're talking about the intervals. So domain, range, and then we'll do the intervals. Domain, range. I'll do that one here. Domain, range. All right. So let's look at C. What is the furthest that it goes to the left? -10. And the furthest it goes to the right? +10. Yep. So it goes from -10 to +10. And you notice it goes from -10 to here at 0, but it only hits it at one point. Then it goes from 0 to 1, 2, 3, 3, and it stops right here, and then it goes from 3 to 10. Okay, but it has a point, a closed circle, or a line everywhere.
So longitude or there's 3 lines.
Right, but it's just the furthest it goes to the left and the furthest it goes to the right. That's fine. The range is how low to how high. So what's the lowest? -4 to 7. Okay, it goes from -4 to 7. It actually doesn't touch 7, so you do want to kind of know that. If they ask, that could be a potential question. It actually touches -4. So -4, it hits that point. It does not hit 7. So you've got to know the difference between those two, that it will not touch -4, but it will touch 7. The domain here on D, it goes from where? Yeah, -11 to 9. So the domain and range on this one's not too bad. And then the range, the lowest it goes is -7. Yep, that's fine. And the highest is 4. So from -7 to 4. Okay, so let's go to E. We can get that one. Domain. This one. -3 to
6.
8.
keep going.
Oh, sorry.
Yeah. It's on your paper too.
I know.
From -3 to 8. And the range is from -4 to 2. Notice none of these have the arrows that make it continue forever and ever. So that's how we're able to put numbers in. And then on F, the domain goes from -4 to 5. And the range goes from 1 to 7. All right. So now the only thing we're going to have to look at are the intervals. So that's the last thing I've got to look at is the intervals. So for intervals, I want to know when it's increasing, when it's decreasing, and when it's staying the same. All right. So on this one, notice decreasing, increasing, decreasing. So I know I'm going to have increasing, and I'm also going to have decreasing. All right. So it is decreasing from what? Decreasing from -10 to 0. So use your x values when you're talking about increasing and decreasing. So it's decreasing from -10 to 0, and okay, and we could kind of use a U there because that shows that there's a break. It's kind of it's our symbol for that, and it's decreasing from 3 to 10. So it's decreasing in 2 different points, from -10 to 0, and then again from 3 to 10. But it's increasing from 0 to 3. So we've got our increasing interval, and we've got our 2 decreasing intervals. Okay, this could be a little bit trickier here. This one's going to be decreasing, then increasing, then decreasing. So we got 1 increasing and 2 decreasing. All right, let's try the increasing one. So I'm going to say that it stops right here. That's the bottom. That's where it looks like it bottoms out. And I'm going to say it hits the top at, I'm going to say right there. So it's increasing from, where would this be? It's in the middle of one. Yeah, I think -6.5 is right in between there. But if you said -7 or -6, you would probably still get credit there. So from -6.5 all the way until 3.5, it is increasing. Okay? Now, it is decreasing the other ones. So that would be from -11 to -6.5. So it's decreasing from -11 to -6.5, right?
Mm-hmm.
And then it's also decreasing from 3.5 to 9. So you had 2 decreasing intervals. Okay, and we get to the last 2. This one we have 1 decreasing and 1 increasing. So here it is decreasing from -3 until we get to 2. So from -3 to 2, it is decreasing. Remember, you're always looking at your x values when you talk about increasing or decreasing. And then, as our x is at 2, it's increasing all the way till our x is at 8. That was a pretty easy one. Over here, I've got a decreasing, then I've got an increasing, and then I've finally got a constant. So over here, it is decreasing from -4 to -2. It is increasing from
-2 to 0.
-2 to 0. And then it is constant from
0 to 5.
0 to 5. So notice what should happen is when you do decreasing, increasing, or constant, you should fill up your entire domain. So if your domain goes from -4 to 5, this should go from -4 and end at 5. If your domain goes from -3 to 8, your decreasing and increasing should go from -3 to 8. So basically you should fill in all those gaps in your domain from whether it's increasing, decreasing, or constant. Now, what's true, if you notice all four of those are functions, even the other two above. So all 6 of those were functions. They all passed the vertical line test. So they each one of them would have been a function. So it does work for that. Okay.